Okay, so in this particular section, I will be introducing you to integration. Now, integration is just anti-differentiation. So what does that mean? You're going back from the original function. You're going back to the original function. From what you have differentiated, you're now going to take it back to what you have differentiated. So how do I mean, or what do I mean? You remember before now, I told you when you differentiate a function over here, when you differentiate a function, let's assume xn is power n. The general formula is that we take n and multiply, so we have n, then we have x, right, raised to power n minus 1. So if we differentiate, if we integrate this guy, integration like this, so if we integrate that guy, we are going to get something very reasonable. If we integrate this guy over here with respect to x, we should get plus 1. So we have n plus 1, then divided by what we have here, n plus 1. That's just what integration say we should do, and we put plus c. Now, why are we putting plus c? Because c, the thing is that when you do a differentiation, right? Let's use a particular figure, for instance. So let's say an example, x raised to power 2, right? So if we want to integrate this guy, we integral of x to the power 2 dx. So this guy is going to give us the function, add 1 to it, and divided by 2 plus 1. Then this is going to be, what's going to be? It's going to be x raised to power 3, right? So this is going to be divided by what? By 3. Now let's see something. Let's see something. If we differentiate this guy should give us 2x. So let's try and integrate this guy and see if it will give us this one. So if we integrate 2x dx, let's see if it will give us this one, right? So simply put 2x raised to power 1 plus 1 divided by 1 plus 1. You can clearly see that this is 2x is power 2 upon 2. You see? So this is giving us back our original function, but we have to include plus c. So why did I say we should include plus c? Let me use this one because you'll be familiar with this one. So this one, if you look at it, is like linear. It's linear. It's practically linear with a slope of 2. So if I'm supposed to graph this guy, definitely you can see the intercept here is 0. So this guy will pass maybe through this origin, depending, right? But we don't know this. We integrated this is a constant. If had it been, we have a constant here, right? Like let's say this guy is x squared plus 1. If we differentiate, we're going to get 2x. If this guy is x squared plus, let's say 1 million, if we still differentiate this, we're still going to get 2x. But we don't know if there is a constant here. So that's why when we integrate, we have to put a constant, because this same 2x, depending on the differentiated value of this, the constant can be somewhere here. The constant can be somewhere here. The constant can make you intercept somewhere here. You understand? The intercept may be different. The original function, you don't know which constant was there, right? So one of the reasons why we have to introduce this constant, right? You don't know, there are indefinite integral present of the family of the derivative of this function. There are just so many of them. So all functions of this form, where there is a constant, right? They have the same derivative. They have the same derivative. I told you, if it is 1 million, it will be the same derivative. It is 2 million, even if x squared plus, let's say, a fraction. When you still differentiate this, you're still going to get 2x. So for that reason, if you're integrating back the function, you have to introduce a constant because you don't know which constant was differentiated, something like that, right? So it makes sense. Good. So we can now take some other examples, right? So this is the general form, like I said. So we can pick some example. Let's pick some example and solve them. Some simple examples over here. So for instance, you are given to integrate if you differentiate x is to the power 4, if you differentiate. So that's why we first of all learn differentiation before integration. If you differentiate this, you get 4 multiplied by 8, 4x raised to the power what? 4 minus 1, which is 3. So let's try and integrate this and see if we're going to get this. So the integral of 4x cubed dx. So we're going to get something like what? 4x raised to the power 3 plus 1 divided by what? 3 plus 1. We're going to get 4x raised to the power 4 divided by 4. This is going to go. So you have to introduce your constant because we don't know the constant. But you can see clearly that it is giving us back our original function. Similarly, if you have square root of 2 dx, from your indices, you can turn this to x raised to the power half dx. So if we do this properly, all I'm supposed to do is to add 1 to this and then divide, right? So let's do it. So our solution will be x raised to the power half plus 1 divided by 1 over 2 plus 1. If you do this properly, you know this over 1, so this will give us like LCM is 2. We have x raised to the power, we have 2. 2 into 2 is 1. 1 multiplied by 1 is 1. 1 into 2 is 2. Multiplied by 1 is 2. Right? So this guy is going to give us like 3. 3 over 2, right? You know you have to introduce your c plus. So we have x raised to the power 3 over 2. So we have something like divided by 3 over 2 plus c. So if you can change this to multiplication, the denominator will go up. So we have 2 over 3 multiplied by x cubed divided by 2 plus c. So this becomes your solution to it. As simple as that. So do we have any other one we can try before we see the general function? So this particular, you can see this particular become the general for polynomial, right? But in this condition, remember, I told you, if n is equal to minus 1, it will not be in our domain. So n must not be equal to minus 1. You have to apply this condition at every time. So good. So let's see if we have x raised to the power 5. I have to integrate it with respect to the x. Very simple. So it's x raised to the power 6 upon 6 because you just add 1 and then divide by everything. Very simple. So you have x raised to the power minus 2. You are integrate with respect to the x. Put your constant, please. So here we have add 1 and divided by 1. So here we have x raised to the power minus 2 plus 1 divided minus 2 plus 1 plus c. So we are going to simplify this guy. What are we supposed to get here? You're going to get x raised to the power minus 1, then multiply by, divided by minus 1. So we can plus c. So we can change this to minus x minus 1 plus c, which is literally minus 1 all over x plus c, right? So always remember you can do this, and then it is very simple. So similarly, if you differentiate ln x, you're going to get 1 all over x, you remember? So if you integrate 1 all over x, yes, your answer will be ln natural log of x, absolute value of x, then plus c. So you remember if we differentiate sine, we are going to get cos. So now if we integrate cos, what are we going to get? We're going to get sine definitely. Then you have to add plus c. So you check all the table I've given you. If you have any question, you can put it down. And also, if you need what I'm using, the material I'm using to teach you, I will send it to you in the live class. Then you try some example by yourself. So try this before we meet in the live class. You can try this before meeting the live class. X raised to the power 7 dx integrated. Integrates x raised to the power 1 all over 3 dx. Integrates x raised to the power minus 4 dx. You can do them by yourself. And then what again? What again can we do? It's very simple. It's very simple to understand. Looking for more, yeah, you can do integrate 7x raised to the power 4 dx. So you can try 1, 2, 3, 4 before we continue in the live lesson. Thank you and see you later.